Thank you, Julianna. I'm Kris West, and together with my co-presenters, Derek from S&P, Rob from FINOS, and Julianna Langston from interoperate, we're going to talk to you about some of the FDC3 community's work to bring FDC3 to web browsers, including why did we need to do it in the first place, how we went about it, and ultimately what the solution contained. So first we need to talk about why we do it. I actually work for a firm that publishes a web-based desktop agent already. We're able to use FDC3 in the browser, and it definitely helps us move beyond addressing just work use cases involving trader desktops, but going across all financial applications. However, there's a catch. FDC3 was originally designed with container products in mind. And there are things that you can do in containers that are much harder in the browser or impossible by design. That includes our main mechanism of getting at FDC3. It's typically injected into a web application by the container that it's running on, and applications pick it up at a standard location, window.fdc3. But we can't actually do that in a browser. So instead, you have to import a vendor library into your application to make it work. And the problem with that is it means you only support that specific desktop agent. And basically, one of the main reasons for having a standard for interop is that application vendors can write once and run anywhere under any compliant desktop agent. If they had to incorporate a particular library, that's actually broken down. Now, that's not a problem if you're building a platform with lots of your own applications talking to each other, but as soon as you want to interoperate with third-party applications and other firms, it becomes a problem. You're back to making a prior bilateral agreement on a particular vendor that you're working with, at which point there's not as much point to working with the standard. So back at the beginning of 2023, the FDC3 community agreed that this needed to be addressed and that we'd form a group to actually discuss and work on proposals to sort it out. That group kicked off in February that year and has had fairly strong participation across the FDC3 community. Early on in that process, by the end of March 23, we agreed that FDC3 should address sort of four main use cases. The existing container or browser extension use case where you can inject the API, but also web-based desktop agents where applications are started as children of the desktop agent, either by opening them through the FDC3 API or clicking on some sort of launcher and starting an application. Those windows will typically be realized by sort of window.open to open a new browser window or adding an iframe to an existing window. We also wanted to try and support independently opened web applications. So if somebody types a web address into the browser and goes there, you need to do different things versus if it was started by the desktop agent. And lastly, there was something we had to mint a term for, I think that Derek came up with, which is a micro front-end container, which is essentially a single web page with lots of different applications running in one DOM. And they need very slightly different techniques. We're not going to talk about that as much today. It's largely solved and solvable by the same techniques. We just don't have time to cover everything. The group also agreed a number of requirements straight away. First on the list was to enable those use cases in a vendor-agnostic way. That was the point of doing the work. We want to support existing FDC3 applications and desktop containers, etc., without breaking changes, because that's a difficult thing to do to an open source community that will try to make everything work together. And we want to allow desktop agent implementers to innovate in the designs of their desktop agents. So the solution needed to not be too opinionated about the structure of that desktop agent. We agreed an approach as well, which was to build a communication mechanism based on standard web APIs, things from the HTML standard, and come up with an FDC3 wire protocol, and then to implement support for that, software support for that in the FDC3 NPM module, so people could start working with that directly instead of necessarily having to go straight to the vendor libraries. So with that, I'm going to hand you over to Derek, who's been with us throughout the process and that working group to talk about some of the challenges we identified that the group needed to solve in coming up with a proposal.
Right, so in terms of the challenges, the first one was really to support all different types of desktop agents. Now, agents are predominantly supplied by FDC3 and container vendors, but proprietary DAs also do exist in some large organizations. This means we need to make as few assumptions as possible about an agent and where an agent runs. And we need to support a variety of different implementation patterns. We can see on the left, we've got an agent running in a main window, and we've got two apps connecting with it via local browser messaging. And then on the right, we've got an agent running in a cloud service with two apps connecting via WebSockets messaging. The next challenge is really around different app delivery models. This relates to the fact that we wanted to support the concept of container-agnostic apps. Essentially, this means supporting different window topologies. So we can see in the center here, we've got apps C and D that are running in iframes inside a platform's main window. Over on the right, we've got apps E, F, and G running in iframes within a layout manager, within a workspace window that was spawned from that web-based platform main window. And then on the left, we've got apps A and B that are running in full windows in their own right, but also spawned from the main window. The next challenge is really best described as agent discovery. So in a desktop container context, the opener is responsible for injecting the FDC3 API into the application, but in a browser context, this mechanism essentially needs to be reversed. So the app must discover and acquire a reference to the agent based on the platform that opened it. We need to be mindful of the fact that the app might be spawned by a variety of different techniques, and we also need to support failover to provide app vendors a little bit more flexibility to support an alternative discovery technique if they wanted to. In terms of communication, the important consideration is that we need to support cross-origin comms. This means we can't use something like the broadcast channel API, but we can use post message and we can use channel messaging API. Once we've discovered the agent we want to use, or rather the app window's discovered that, the next challenge is then to acquire it. So one possibility is to use something like a dynamic import expression. This has the attraction of simplicity, but it's inherently insecure. There's no sandboxing. Now, we can mitigate against some of that risk using content security policy, but because this is inherently risky, this doesn't belong in the FDC3 standard, so we can discount that. The next possibility is to use a shared web worker. This technique really relies on you creating hidden iframes inside app windows, run the iframes on a common origin, and then use a shared web worker between the different windows. As it turns out, you can no longer do this on a full cross-origin basis based on recent changes by browser vendors around tightening up privacy. So we can discount that as well. The next possibility is to proxy to an agent that's running in a main window. This is secure because it benefits from standard browser sandboxing. This also requires a standard wire protocol. So we can use this. There's a variant of this technique as well that relies on dynamically creating a hidden iframe in the app window, installing an agent in it, and then proxying to it. This is secure and requires a standard wire protocol in the same way as the previous technique. There's a nuance to this one because it does slightly better support cloud-based agents because it doesn't require a main window to remain open for the whole duration of the user's session. So again, that's something we can use. The next challenge is around identity. Now, running FDC3-enabled apps on the web definitely does increase the potential attack vectors. That's something we need to be mindful of. And this means that app identity and the app directory becomes even more important. In terms of navigation, desktop containers traditionally tended to assume this didn't happen. In fact, this can happen. And actually, as it turns out, it's more likely in a browser-based context, not least because you have an address bar. So we need to be mindful of the fact that an app running in a window may not be the same app that was originally opened in that window. In terms of refresh, we need to be mindful of the fact that when a window is refreshed, the app inside it needs to reconnect to the same desktop agent that it previously connected to prior to the refresh, and also it needs to be acknowledged as the same app instance as before. And then finally, just to wrap up on these challenges, there's two further things around surfacing UI content and supporting user interaction. This is required for intent resolvers and channel selectors. And the challenges here really are around the fact that if you've got an agent running in another window, it can't surface UI content directly in another app window. There's additional challenges in terms of things like propagation of user gesture context on a cross-origin basis. This can be problematic if you want to do something like invoking a window.open to serve as UI contents. So this means we need a secure and a reliable way to provide intent resolvers and channel selectors. So that's it from me, and I'll hand over to Rob, the demo.
Hi everyone. Yes, my name's Rob from FINOS. So Derek's kind of laid out all the challenges there. And in working on this project, we realised we needed somewhere where we could test out our ideas. And so we put together a proof of concept, which I'm going to show you now. Now, this is a proof of concept, so it looks kind of bad, but it does demonstrate all the different bits of FDC3 that we want to talk about. And this is something we've been building over the last few months and trying things out in it, trying out our ideas. And so the first thing we tried out, so just to set the scene here, this is actually a desktop agent implemented as a web page. I've lost the Chrome off the top of the web page. Let me just put it back like this so you can see it's an actual web page. So, so the first thing, so FDC3 contains a bunch of different functionality. One of the ideas of FDC3 is that one app can broadcast to another app. So this is the first thing we tested out. So I ended up building a couple of apps here, the broadcaster app and the receiver. And if I press the start button, these apps start up. And if I go to app 1, I can press the broadcast button. And then in app 2, you can see messages being received. So this is one app broadcasting to another. And if I start another copy of that receiver, you can see, that's also receiving the messages as well. So this is actually a bit of FDC3 functionality happening in the browser. And if I go onto the desktop agent and I show you the console, you should be able to see all the FDC3 messages sort of flying up the screen here. These are all in the new FDC3 protocol, which Kris is going to talk about in a few minutes. So this was the first piece of functionality we started with. So that's broadcasting. The second bit that I want to show you is, so FDC3 has the ability to raise and resolve intents. And so I'll close these down. And I'm going to click on the FDC3 workbench here. So people who are familiar with FDC3, this is like people who aren't familiar, this is a kind of like a tool for testing out FDC3 that's been in the FDC3 toolbox for quite some time now. And obviously this is now working in FDC3 on the web too. So if I go to intents, I'm going to raise an intent. So I'm going to use an instrument example, and I'm going to choose to view a chart in it. So if I press raise intent now, what happens is this is another app being loaded. This is Chart IQ, which is another quite famous FDC3 application, again running in the browser. And it's showing the Microsoft draft here. So what happened was the FDC3 workbench raised an intent, and that was handled by Chart IQ. And intents can return results as well. So a quick example of that is that if I choose the view quote intent and raise that instead, so this is asking for a quote from another application, it starts up this app 5, and in the FDC3 workbench I can see the result coming back here. So it's got this little bit of data coming back. So that's one app talking to another based on some user wanting to do something. And all of this kind of looks quite dreadful, but in a few minutes Julianna's going to show you how all of this is customizable by the desktop agent vendor. So it's almost a good thing that this is looking bad, that's what I'm saying. The last thing I wanted to just show you before I move on is, so part of FDC3 is user channel selectors and intent resolution screens. So these are bits of UI that are handled by the desktop agent. So, and again, we have like a really simple implementation of these inside this desktop agent, FDC3 for web desktop agent. So if I click in this corner here, I get this like really noddy channel selector, and I can select a channel here. I'm now on the green channel. If I go to the user channels tab here and refresh, you can see it says channel 3, which is actually the third channel on this list. So this is showing you a little bit of UI that the desktop agent is providing to the workbench. And by the same token, if I go back to the intents again and I select view news, so this is asking for some news about that Microsoft instrument, then this is the intent resolver. So this is where you have multiple applications that could be solve the view news problem. Please choose the one you want, and you can choose the application that you're interested in. So this is all sort of very sort of like, it's just our sandbox for playing with these ideas. Now, the last sort of thing I wanted to talk about is we have this project called FDC3 Conformance Framework. And the idea of this is to sort of test desktop agents and say, these are all the functions that FDC3 provides. Can we make sure that all the desktop agents provide the same functions? And in the FDC3 project, we actually report on the conformance of various different vendor desktop agents. So if I show you here this conformance page, in FDC3 2.0 conformance, you can see my colleague Kris's Interop.io product has 2.0 conformance, and OpenFin has been rebranded recently, so we need to update this, but this is listed here as well. So the question is then, can we build an FDC3 desktop agent that passes the conformance tests? And this is what we've been working on recently. So this is, I'm not going to run this now because it takes too long, but these are the conformance test results for the on-the-web FDC3 desktop agent. So you can see it's getting a clean sweep of passing conformance tests. So again, this kind of demonstrates that we actually can build this stuff. I'm going to pass back to Kris now. He's going to tell you a little bit more about the implementation.
After you show me where Keynote's hidden itself.
Yes, let's see if we can find that.
But while he does that, I would like to say thank you both to Rob and to FINOS for giving us Rob's help to actually prove out some of the things we were talking in the meeting. So although it may be, as you said, a little bit of a rough demo, it's very much proving the technology concepts that are going into the proposed solution. And I'm going to tell you a little bit more about that solution as quickly as I can and what it's going to do to your applications if you're working with FDC3. Well, basically, as we said, our goal was to standardize a vendor-agnostic solution for communicating with the desktop agent. The job is basically to give you an option to use the FDC3 library instead of a vendor library to connect into the desktop agent. It doesn't stop you in other applications using that vendor library if you only run in that agent. We need to implement support for it in the NPM module. And to do so, we basically had to invent two things: the FDC3 Web Connection Protocol, a procedure for locating the desktop agent, providing an application's identity and securing the rest of your communication, and then the FDC3 Communication Protocol, which is the standardized set of messages that supports all the API calls and events. So starting with the Web Connection Protocol, it provides standardization for that means of locating the desktop agent, which we'll go into in a minute. A message transport for us to actually use in the browser, which we've chosen the channel messaging API for, and message ports. Storage for instance data, which we use session storage for from the HTML specification. And finally, a method of validating app and instance identities in a browser. It's a fairly flexible approach. It supports multiple different formats of web-based desktop agent. DAs can communicate directly over it or pass details of an adapter, and we communicate with the adapter instead. And finally, it provides a sort of failover to an alternative approach which can use the same communication or something else that implements the desktop agent interface. So to establish a connection to a desktop agent, we first have to check if it's a new connection. Have we navigated or refreshed? And we go to session storage for that. The data there allows us to force using the same desktop agent type and to gather any past instance details for the identity validation step. If you're not familiar with it, the session storage API is very similar to local storage, which is more often used. But the difference is it's scoped to a particular tab or windows, which makes it very useful for our instance data. Then we deal with our various use cases. Our first one is the existing containers use case. And as you do now, the protocol checks for window.fdc3 and listens for the FDC3 ready event if it's not there, basically to identify the agent and then just pass that back through to the application. So nothing much has changed there. Our second use case is new browser windows. So essentially you've got a main browser window with the desktop agent in it. It's opened another window. In the HTML standard, you get a reference back to that window through window.opener, and you can conduct some messaging with that. You might also have a single window with the desktop agent in it and the application's loaded into iframes, in which case they'll find a reference to their parent at window.parent, and you'll need to communicate with that. And of course, we can combine those two cases. We might have opened a new window, have a layout manager window that has iframes, in which case you're going to go to window.parent.opener. And then once you've got your reference here, you send a message to it by the window.postMessage API, which is how we actually start doing channel messaging. And it's a standardized hello message. I'm looking for a desktop agent with a few settings, and it will go to any or all of those references that are set. And we're looking for a standardized response in the form of a handshake message back from the desktop agent. And that will contain one of two things, either a message port, which will conduct all future communication over, which will be secure between the desktop agent and the FDC3 library, or it can actually send back an iframe URL, so a URL to load into a hidden iframe, which the adapter will create, and that can work as an adapter to the desktop agent in some way, and we'll use the same methods of communication with that. It's just acting as a proxy. And then if we don't find any of those, so for example, the user has just typed in a web address, there wasn't a parent desktop agent, the application can provide a failover function allowing it to do something else. That could be create a hidden iframe itself and load an adapter of some sort into it, which we can then communicate with, or they might just start an adapter more directly and pass that through. As long as it implements the desktop agent interface, it will go through and work just fine. We then have to go about validating the application's identity, which we plan to do through an app-supplied app directory record. At the moment, it's usually the desktop agents using the app directory to start applications, but they're always expected to be associated with the apps, and it's an ideal place to put some identity information. So apps will identify an fully qualified app ID or a URL to their appd record. That will get passed through to the desktop agent, which is expected to retrieve the record, have a look at it, and use it to validate the identity of the application. We've agreed a really minimal spec for that validation initially, which is to use some browser-supplied information about the origin of the web page, compare that to the appd record and some allowed origins, and we're essentially using the DNS system to confirm ownership of the app. If it's where we expect it to be, somebody owns that domain name and they should be the right publisher. This is intended to be a temporary solution, however. There is an identity and security group also working in FDC3. They're going to make some recommendations regarding the identity of applications, probably using a public-private key system, again, involving the app directory record, so it'll be easy to extend our approach to doing that. But we don't want to create two competing proposals for that type of security in FDC3. And then lastly, instance identity is also validated via checking that it's the same app ID and a shared secret that's passed over during the setup process. We then persist all those details to ensure that we get the same desktop agent next time, the same instance ID if we are the same instance of the app, and we could also make it somewhat robust to the parent window closing. For example, if you had to load an adapter, we can hang on to the URL for that, and even if the parent's gone, we can still load that adapter up and see if we can still connect to what we had. So from there, we start using the communication protocol. That goes over the message port or through those various references I've mentioned. And it's basically a comms protocol defined in JSON that supports all of the API calls and events in the FDC3 API. It's defined in JSON schema, which is the same system we use for defining context and bridging messages. And they will typically have a sort of type, payload, and metadata structure. I will save you all the details of all the messages. There are many of them. But ultimately, it's used to implement something we call desktop agent proxy. It implements the desktop agent interface and will just handle the communication back to the desktop agent for you and giving you your results back. There are also a number of other potential use cases for such a wire protocol, such as standardized adapters for other languages could use a similar setup. And then pretty much last detail is the utility function that you're going to use to actually get hold of the agent. So this will be the thing that most app developers actually run into, and it's designed to support all those use cases. So you will essentially call getAgent from the FDC3 module, give it an app ID, give it an indication of whether you want a channel selector or an intent resolver, and you'll get an FDC3 reference back. You can also provide a failover function if you've got another method of starting a desktop agent or associating with one you want to use, so you pass that through. And then to retrofit your existing apps, you're essentially just going to have to add that one call instead of looking at window.fdc3. And if you don't want to change the rest of your code to use the returned reference, you can just set it back on window.fdc3. And with 2 lines, you've essentially retrofitted for working on the web. This is expected to be, is proposed to be the recommended approach for getting access to the FDC3 API because it will work across all the different cases. So it will replace checks on window.fdc3 and using that FDC3 ready event. So with a bit of luck, you'll actually save a couple of lines of code on retrofitting your app. And with that, I'm going to pass you over to Julianna, who's going to show you what it might look like in future. Just leave that there. You can pop on top.
Okay, so Derek told you about what could and couldn't work. Kris told you about those specific implementation details, and Rob showed you a nice sandbox that we used to prove it all out. Well, after Rob built this sandbox, I wanted to see if I could build a nice little sandcastle with it. So here's my little sandcastle. So we've got a blotter on the left, we've got a little bit of a chart on the top right, and then I made a little spider graph. Let's just pretend that's our internal application and not these whitelisted pre-existing applications between AgGrid and ChartIQ. And so I just want to show you how we're going to get them all together and see if I can do it in 60 seconds. So you can see that in the bottom right of 2 of these applications, we've got a little red cube. That's all I got left. We have a little red cube. They're both on channel 1. That means that these 2 applications with the red cube are going to be able to talk to each other. And the one with the black cube, the one in the bottom right, not going to be able to talk to each other. So let's see what we can do. Let's go ahead and just show you them sharing context. We've got a...
You've got 5 minutes, Julia.
I've got 5 minutes? I thought I had 1 minute.
5.
I thought it ended at 1:30. Okay, well, great. Okay, as you can see, the context is sharing, and I'm now going to talk a little bit slower. Context was shared between those 2. We can come back over here, and I don't know, let's say we'll share Microsoft there. Contexts are able to share back and forth. That's great. That's how we expect channels to work. But what if we wanted to do something else? We could also view a chart and say, oh, sure, I want ChartIQ to show me that chart. It shared that data. Great. What if instead the spider graph, it's over here, it's being lonely. What if it wants some data? Great, we can do that. It's called overview, by the way. That's how good at naming I am. And there you go. You can go ahead and share data between those 2. That's great. That's pretty much what we expect FDC3 to do. And look, it's on a browser. We're all very excited about that. But one of the great things about browsers, you can have multiple of them. Can't have multiple desktops necessarily. It gets kind of hard if you try to network that. But we can have multiple browsers. Great. What if we want to do that? So I'm just going to say view chart, and I'm going to open a new app, so in a new window, and let's see ChartIQ. And that opens up a brand new app in a brand new window. Now, if I had a whole bunch of windows up, I could move them around, I could position them all we wanted to, but that's just your basic idea. Can we get a couple of apps, have them all play nicely, and make it all feel a little seamless, a little all held together? And that's pretty much what I have here. Anyone have any questions either about this or FDC3 on the web generally? Yes, I've got a question back there.
Is there a plan for a workspace, the web version?
Essentially, we have covered how you would build those. So it's expected you still work with the desktop agent provider, a vendor who will implement something like layout managers, for example. iConnect Browser allows you to lay out a bunch of browsers in exactly what we call a workspace window. So it's been designed to support those use cases. It wouldn't be something that you directly implement in the FDC3 module, which is just there to provide connectivity back to the desktop agent, as well as types and other things that are going to make it easier to write your messages in your apps. I will.
Is there any plans here to, I mean, at the moment this is all scoped to a single browser, right? So Chrome or Firefox, but not both. Is there any, or OpenVIA for that matter as well, so is there any plans to be able to do platform, if you like?
Well, there certainly is. There is a 5th part to the FDC3 standard we introduced in 2.1, which is called desktop agent bridging. And its job is to connect the different containers to each other, or I shouldn't say containers, sorry, to connect the different desktop agents to each other. So a web-based desktop agent could be talking to a product on the desktop, like iConnect or OpenFin or something in-house. It could equally be talking to another browser-based desktop agent at the same time. So that is the job for the desktop agent to do, but it's been designed in such a way that they can very simply connect to each other and allow things like context sharing or raised intents to cross the boundaries between them.
The intent resolver UI that overlaid when you clicked on that button,
Yeah.
where did that come from? What owned that? Is that the app on the left, or does that come from the agent?
But something we didn't think we'd have enough time to cover exactly how we've gone about doing that, but the desktop agent is actually providing a URL where you can find a little mini application that's being injected into an iframe again. And the library code is actually managing display of that. And then there's a very similar, very basic bit of messaging between the library and that intent resolver, so it knows what's going on. It's been done in its own iframe, so it's sandboxed away from the application. We don't really want to start opening holes for code injection. But by putting it in a sandbox iframe, communicating with it, we've basically summoned it, fed it the options, and had it come back. Had the results come back from it. You've seen two different ones here. They've been injected the same way by different implementations, by Rob and Julianna. So the idea is that the desktop agents should still be able to supply these. They can still innovate in the design and implementation of them. But we found a secure way of getting them into the app and making them work. Okay, so throughout we've tried to keep, security has been a big topic here, as you've heard us say it a bunch of times. But really, the things we could do, as Derek said, would be really easy with code injection, but we'd be opening up lots of horrible holes. So we've had to put more work into making this work securely, soundly, and allowing desktop agent vendors or implementers to actually implement the things they want, the UIs they want to push. At the meetings, we heard that, for a lot of people putting out desktop agents or building platforms with them, they're looking for that consistency, and they're looking to not have to, so consistent UI across different applications for something like an intent resolver, and they don't want to put it in every application. They want the desktop agent to be able to do that. So that's what we work towards. Okay. If there are no more questions, basically next steps for this project, I'm going to forego switching back to the presentation for this, but we've got work to do writing up the documentation for this. There's a big PR and lots of message schemas and other things that are in progress that are going into the FDC3 Standard. That will then have to go to a vote of the community for adoption, and adoption of what we hope will be FDC3 2.2. It's a non-breaking change. It's a new thing that you can use. We're hoping to make it the recommended thing that people will use going forward, but it won't break the existing applications. You'll hear from us on the FDC3 mailing list and the FDC3 meetings about that adoption vote. There'll be more detail on the proposal. You'll be able to review the documentation for it and the software, as we're going to have to release quite a lot of that in order to make it happen as well. So we're always looking for participants, whether it's on an editorial basis, reading through and giving it your rubber stamp of approval that this all made sense, you were happy with it. But also, we're always looking for implementers to support the POC work and the productionization of that code into the FDC3 module. So if it's something that's going to be important to your organization, do get in touch with myself, Derek, Rob, Juliana, any of us, and we'll help get you started and find a way that you can contribute to the effort.